Hello, this is part 2 of a series of videos in which I explain some of the mathematics behind my animations. In this second part of the series, we will look at curves called hypocycloids. In part 1, we looked at epicycloid curves, which are the curves made when one wheel rolls around the outside of another wheel. In this talk, we will look at the patterns created when one wheel rolls around the inside of another wheel, like this. This type of curve is called a hypocycloid, from the Greek words meaning below or inside a circle. In this case, the outer wheel is 3 times the size of the smaller moving wheel. So we say the ratio of the wheel sizes is 3 to 1. Tracing a point on the edge of the moving wheel with the red pen, we can see that the hypocycloid curve touches the outer wheel at 3 points as it goes around. Just as with epicycloids, we can draw hypocycloid curves with different ratios. Here are the hypocycloid curves with ratios 3 to 1, 4 to 1 and 5 to 1, drawn in 3 different colours. And we can draw more complex hypocycloid curves. Here are the hypocycloids with ratios 7 to 2 in red and 7 to 3 in green. Notice that the red and green curves touch the outer wheel at the same 7 points, but they visit these points in different orders. The red curve with ratio 7 to 2 touches every second point, whereas the green curve with ratio 7 to 3 touches every third point. You might like to predict what shape the curve will be if the ratios of the wheel sizes is, say, 11 to 4. At how many points will the curve touch the outer wheel? In what order will it visit these points? If we draw the curve, we can see that it touches the outer wheel at 11 points and goes around visiting every 4th point. I have drawn the 11 arcs of the curve in different colours to make this more visible. We can get even more complicated patterns by combining epicycloids with different ratios. For example, we can use 3 wheels with sizes in the ratio 8 to 5 to 3. The smallest wheel rolls around the inside of the middle-sized wheel, and that wheel in turn rolls around the inside of the largest outer wheel. This is the pattern we get if we put a pen on the smallest wheel. I've taken away the wheels and just left the pattern to make this clearer. In the next video, we will look at the patterns we get if we put pens at different places on the moving wheel.